Except for, whoops, that's the assignment. Alright, so today we're going to talk about domain and range. So it'll have a tiny bit of review from yesterday, but then we're going to go over how we can calculate it both algebraically and graphically. So don't forget your setbacks. We're going to talk about domain and range. Alright, so just a reminder of those basics we did talk about yesterday. We talked about how the domain are the x values, they're the input numbers. And when we talk about domain, we're talking about all of the possible x values. So everything that could go in for x and have our function still make sense. And when we talk about range, that's all of our possible y values. What are the possible numbers that could be our inputs? And we will be using set notation to describe our domain and range. And so that's kind of why we did that set notation in the background knowledge chapter. Remember that if we're talking about the domain, for example, we're going to use something like this, like x such that, and then whatever it happens to be. So we're going to write our answers like that today in that set notation. So there's just a couple of things that we just cannot do. And you guys know this. I know you probably plugged something in on your calculator and it's come up domain error, or what's another way it comes up? What was another one? I'll remember it. Syntax error. So the thing is we cannot square root a negative number. We're not doing imaginary numbers right now, so we cannot square root a negative number. You'll get an error message if you do that. And you can't divide by 0. We know those things, right? So the thing is when we do something or try to do something like that, under those circumstances, the function is called undefined. So sometimes I think it comes up undefined on your calculators too, like domain error or undefined, because whatever number we would put in would make our function like impossible. So that number cannot be a part of our domain. So the first thing we're going to do is look at the algebra and how we can figure out by looking at the function what numbers we can't have. So algebraically, the domain includes all x as long as the function remains defined. So as long as we are not dividing by 0, as long as we are not square rooting a negative, every other number will work. So part of what we will be doing will be seeing if we can figure out, okay, what doesn't work. Once we know what doesn't work, then we can fill in what does work. So we're going to do 4 examples algebraically, and then we're going to look at 4 examples like the graphing and see how that goes. So the next 4 examples are going to have the same exact directions. State the values for which f of x is undefined, and hence state the domain of the function. So we're going to really focus on stating the domain of the function, just that sometimes part of it is we have to figure out, okay, what can't it be? Where is it undefined, and then we can write where it is defined. So our first example is f of x equals 5x plus 3. So we're going to look for those two situations we can't have. Is there any square rooting happening here? Nope, don't gotta worry about that. Is there any dividing happening here? Nope, don't gotta worry about that. So when everything works, we would say x such that x can be any real number. So x says that x is a real number. Because it doesn't matter what number we put in there as long as it's real. Is everything okay? It looks crazy? Okay. Then let's try and make it less crazy. So this x means we're talking about like our inputs, our domain, right? Later we're going to do range. We're going to wait until we have graph to do the range, but ranges are the y values, right? So when we do range, we're going to have y. This just means we say such that. So that kind of tells us what's going on with the x. So the x is, okay, what's going on with the x? This just means an x is a real number. That little kind of weird E symbol means like contains or is a part of. So the x is a part of the real numbers, and all the real numbers work. I can put 2 in there, I'll get an answer. I can put -2, I'll get an answer. I can put 1/2, I get an answer. I can put the square root of 7, and I'd still get an answer. So all of those things would work, any kind of real number. Does anyone recognize this type of function for bonus points? Like if I graphed it, what would it look like? I thought you were doing it with your arm. A line.
Oh, is it linear?
Yep, it is. It is a linear function, and you're going to notice that linear functions are pretty much always all real numbers. Because there's nothing you can put in a linear function that's not going to give you an answer. So just kind of a tip, if you see linear, it's probably all real numbers. All right. Next function, g of x equals the square root of x plus 3. So once again, we'll look for those situations. Do I have any square rooting happening? I do. So we know that this stuff in here cannot be negative. It cannot be negative. Because if it turns out that it's negative, I'm going to get that domain error, it's not going to work out. So what we want to set up then is that stuff that's inside, the x plus 3, has to be, well, it has to be positive, so it has to be greater than 0. But can it equal 0? So, right, it could equal 0. I could take the square root of 0, right? So it has to be greater than or equal to 0. So kind of thinking that through, like, it's okay. If it equals 0, I can still square root 0. But if it equals a -2, I can't square root that. So it has to be greater than or equal to 0. So we can do some solving. So x has to be greater than or equal to -3. Now, again, I'm not so focused on stating the values. The values would be x is less than -3. That won't work. I want you guys to focus on the domain. And so, I forgot, usually I write D for domain, but write your funky parenthesis. We're dealing with the x's. So we've got x such that. Pretty much, we're just going to write this down. X has to be greater than or equal to -3. As long as it's greater than or equal to -3, it will work out. So that is our domain. And we still have 2 more like this, so we'll kind of look at some other different types of problems. Any other questions on that one? All right. So here we have h of x equals 1 divided by 2x plus 3. Do I have any square rooting? No, don't gotta worry about that. Do I have any dividing? Okay, so what do we know? We know that that cannot equal 0. It can be a positive number. I can divide 1 by a positive number. That would work out. It could be a negative number. I could divide 1 by a negative 10 or anything, right? It just cannot be 0. So this one we're going to approach a little bit differently. Mostly the same, but just a little bit differently in how we think about it. We know it can't be 0, so we need to find that one value that would make it 0. So we're going to look to see, when does this equal 0? I'm going to look, so it's a little bit different. Instead of setting up an equation for what works, I'm actually going to look for what doesn't work here. So I'm looking for that one number that will make it equal 0, so I subtract my 3, so 2x equals negative 3. Divide by 2, x equals negative 3 over 2. So that's the only thing it cannot be. If it is a negative 2, that'd be fine. If it was a positive 1, or if it was 0, if it was anything else, it would work. So when I write my domain, x such that, in this case, x cannot equal negative 3 over 2. Everything else will work. Doesn't matter if it's negative or positive or square root. Anything else will work as long as it's not that number. So kind of two different ways of thinking, whether we're looking at square rooting or dividing. We're going to have one more like this before we get on our graphing, whatever's we're using for graphing. Any questions? So I'm going to let you guys take a look at this one. Look to see, do we have any dividing? Do we have any square rooting? What happens then? So I've got x squared plus 6x minus 3. Any square rooting? No square roots. I've got squares, but I got no square roots. Is there any dividing happening here? I've got nothing to worry about. So when I've got nothing to worry about, that means every single real number works. So my domain is x such that x is a real number. Doesn't matter if I put 1 in there, or -1, or -100, or the square root of 7 again. I don't know why I picked that one again. But it doesn't matter what I put in there. I'm still going to get a number. It's still going to work. I'm still going to get an output value. Is it going okay? So we're going to have 4 more examples, but the directions are about to change just a little bit. And for the next 4 examples, we're going to use technology to sketch the graph of the following function and then find the domain and the range this time. So we're going to look at domain and range. Keep in mind, I'm not asking you to have it memorized how to graph these functions right now. You can use technology to do that. I'm going to end up flipping back and forth between Desmos and Prezi so we can see the graphs up here. So the first one is f of x equals the square root of x minus 3. Look on your calculators where it says y equals if you're using a calculator. If you're using Desmos, you should be able to just plug it right in, right? But if you're using a calculator, look for what says y equals, and then type it in. I would use parentheses, like when in doubt, put stuff in parentheses on these calculators. You know better than they do. If you use parentheses, then you can make sure that whole thing is in that square root. Once you have that, then you can go to the button on the right that says graph. And your picture should start coming up. So I'm going to type mine into decimals while you guys go ahead and type that in yours. Alright, so mine's a little slow here. So I've got the square root of, and I'm using parentheses too, x minus 3. Let's go ahead and turn that projector mode on. Okay. Do you guys have something that looks like that? If not, let me know. Maybe we plugged something in wrong. When we want to sketch these, we want to take a look at like the kind of key points. And I noticed a key point right here. Can you guys tell where that is on your whatever you're using to graph? So I'm going to sketch that out, and I'm going to do that. And again, it doesn't have to be perfect. I'll hit graph. See that says graph right there? There it goes. So then when we get back here, when I sketch this again, I'm just going to put like that key feature. Here's my coordinate plane, and I noticed it started at 3, and it looks something like that, right? Like I'm not looking for like this beautiful detailed thing. It's exactly in the right spot, but you've got the right general shape. You've got that key feature. Now we can use this picture to do our domain and range. So the domain, remember, are those x's. So I look at the x-axis. I've noticed I don't have anything over here in the negative. In fact, my first x is 3. And then we have to imagine that this is going to keep going, right? Like I didn't draw the arrowhead, but we could see that it's kind of keeping going. So my x's start at 3, and then they get bigger, so x has to be greater than or equal to 3. So we're using that picture to look for that. And then when I've got the range, now I'm working with y's. So I've got y such that and for these, I have to look at the y-axis, and I notice, again, like I don't have any y's in the negatives down here, right? What's the first y value I get? At 0. So my y's are going to be greater than or equal to 0. So using that technology to get that picture for our domain and our range. Any questions? Again, we've got 3 more, so we're going to kind of look at a bunch of different ones here. Okay. So next up is x cubed plus 2x squared minus x plus 1. So you can go ahead and plug that in, but do you guys know how to plug into the third power in a calculator? What you want to do is when you plug in x, do you guys know how to use that like caret symbol? Or am I telling you old news? Old news, I see some nods like we know this. Okay, good. So then go ahead and plug that in, and then hopefully you've got something like this. Again, if you're, whatever you're using, whatever device you're using, if you're having issues, please let me know. Yep, caret's on the right. Everybody got something that looks kind of like that? So once you've got it, go ahead and sketch it, and then think to yourself, okay, what are my x values? Is there anything on this that x can't be? And then what are my y values? Is there anything that my y can't be? did you guys sketch it already? I gotta catch up. Let's see, it looks something like this. Remember to put my arrows on here this time. We know those arrows mean it keeps going in that general direction, right? So if I think about my x values, are there any x values that I can't have? No, I mean I could keep going, it's going to keep going, and if I keep going negative, it's going to keep going. So for my domain, all those x's work. So remember, we write x is a real number. What about the range? If I'm looking at my y values, do you think that those are ever going to stop? Oh, I got that arrow, like it's going to keep going up or keep going down. So my range is also all real numbers. So the more, like the bigger x's I put in, the taller it's going to get, the higher it's going to get. The smaller x's I put in, it's going to just keep getting lower and lower and lower. So we've got all those. Okay, 2 more graphing ones. Are we all still doing okay? Okay. So up next, we've got f of x equals 1 divided by x plus 3. Keep in mind with your division, you're going to want to use parentheses again. Like I said, when in doubt, use those parentheses. Should look something like what I got up there. If you need help, again, if you need help with whatever you're using, whether it's decimals or whether it's a graphing calculator, just let me know. So again, when you're dividing on your graphing calculator, you got to put parentheses around this. If you don't do it like 1 divided by x plus 3, if you just go like this, I'm sorry, that's an x. Let's say you do it like this, then it's going to do this, 1 over x plus 3, because it's going to divide first, right? Because we know order of operations. So that's why you have to have those parentheses so your calculator knows I'm dividing by that whole chunk. Now when we look at this, hopefully you notice that like my x's are getting really, really close to -3, but then it's kind of stopping. I don't know. What do you guys remember that call? That like line where like things get really close to, but they never really touch. I'm sure that you had it last year at some point in time. An A. Got it? Asymptotes, yeah. So we do have an asymptote here. Notice it's at x equals -3. So that asymptote is actually not part of our domain. If we think about it, if I plug -3 in there, what happens? Divide by 0. We can't divide by 0. So that will not be part of our domain. And look, we also have one here for our range. I notice that it's getting really, really close to 0, but my y doesn't ever actually equal 0. It's just getting super, super close to it. So 0 will not be a part of my range. So I'm going to go ahead and I'm going to sketch this, and then we'll write our domain and range out. So like I said, you just want to kind of put in key features like your asymptotes. And then we can graph it. So then just like we talked about, for those x's, it cannot be -3. So I'm going to write my domain that x cannot equal -3. Cannot exist where I've got that asymptote. And then similarly for my range, my y value is never going to equal 0. We're going to look at the craziest one yet, and then we're going to be done with examples. Are there any questions? All right, here's the last example, 2x plus 1 divided by x. Go ahead and see like what you come up with. It is funky. It's a real funky one. You should have something. Oop, projector mode, come back. It looks like this. I already kind of looked at those like hot spots. Is everyone getting something that kind of looks like that? Kind of like a swoopy thing in quadrant 1 and a swoopy thing in quadrant 3? So when I look at this, do you guys see any asymptotes, like lines that it's not really approaching? Right down the middle here, I noticed that it doesn't really come to x equals 0. So as far as my x's go, x equals 0 will not be part of that domain. The y's are a little bit different, and I'm going to round a little bit, so I'm not going to get super technical. I'm going to round, especially for those of you that are using the graphing calculators. It's definitely harder to see some of those points, but we're going to round these to being about 3, okay? So like 3 and -3, is that okay? Because I noticed that my y's are greater than 3, or my y's are less than -3. You guys with me on that? Can't be 2, can't be 0, can't be -1. So when I think about my range, my y has to be greater than or equal to 3, or y has to be less than or equal to -3. So I don't have any y's in the middle there. You guys kind of see how that matches with our picture when we look at our y's? Maybe not. And again, I rounded it from -2.8 to -3, just because I know that on the old school graphing calculators it's harder to see. So I could be less than -3. I could be greater than 3. So I'll put that one into my domain. So if you guys don't mind, I'm not going to sketch this one out. I feel like you guys have probably got sketching under control. I'm going to jump right to using what we just talked about to do our domain. So the domain, we said, all right, there was an asymptote at 0, so x cannot equal 0. We saw that from our picture. For the range, we noticed that the y's were either greater than or equal to 3, or the y's were less than or equal to -3. We're going to just hit the stop box, and then you guys are going to get the assignment. But are there any questions or concerns you guys have right now for domain or range? Okay. Now, in the stop box, I just really wanted to kind of drill it into what are the things that we cannot do. We can't square root a negative. We cannot divide by 0. So So just like if they're in their stat box, then you can look to that page and you can know exactly. And then a function is blank when in one of those situations. What do we call a function if we try and do one of those two things? Absolutely. So a function is undefined if we divide by a 0. And a function is undefined if we try to square root a negative. And then here we go. I would like to take any of your questions from yesterday's assignment after you guys get a chance to write this down.